7.4 is on complex fractions, and a complex fraction is a fraction where in the numerator of the fraction you have another fraction, or in the denominator you have a fraction, or in both places, as the case with this one. And so here's my main fraction bar here, my main fraction bar, and in the numerator there's a fraction, and in the denominator there's a fraction. The book talks about two methods of clearing a complex fraction, and I want to show you those two methods, and they name those methods Method 1 and Method 2. Method 2 is just simply the order of operations, so I wanted to start off with that one. And what you do is you add or subtract to get a single fraction in the numerator. So right now I have two terms in this numerator, and it's not a single fraction. And so I would treat this like it was one problem and try to subtract those, get a common denominator, all of that. That's what I would do in step 1. And then step 2, do the same thing to the denominator. So here's 3 pieces here. So I would get a common denominator. I'd write the 4 over 1 and get a common denominator and get that to be one fraction. Then what you do is you rewrite it as a division, followed by rewriting it as a multiplication. So some people can go right from here to writing it as a multiplication, but I'm like, get it as a division, then write it as a multiplication, and that gets you to that spot. And then use your directions for multiplying that we learned in 7.2. So we'll give a try to that. This one here is actually quite a bit of work to do with method 2, because you have all that work to do to get one fraction in the numerator and all that work to get one fraction in the denominator. Whereas this one is pretty nice for method 2, because I already have just one fraction in the numerator, and I have just one fraction in the denominator. So I can say done, done. Now I'm on step 3. And so you can learn just one method. You don't have to learn both methods. I only knew method 2 through getting a master's degree in math. And it wasn't until I taught algebra the first time that I learned method 1. And I thought method 1 was so nice that I was always, oh yeah, I'm going to show people that. And so anyway, that's my story on that. And so we'll come back to method 1. So I have the example I was giving you, that is actually problem 14 in your book, and I've asked you to solve that using method 2. So how you would do this using method 2 is, the first step would be to make sure that this numerator is one fraction, and it is, so done. And the second step is to make sure that this denominator is one fraction, and it is, done. So now we're on step 3, and we haven't really done anything, and that's to realize that it's this divided by this. So I'm going to rewrite this as a divide. So it's 3x plus 1 over x squared minus 49 divided by this. And then you can rewrite it as a multiply, right? You can turn this into a multiply and do the reciprocal. I feel like I'm going to run out of room, and so I'm going to go straight out here. So the first fraction stays put. And then I'm going to turn that into a multiply. So right there, a multiply. So a big times symbol there. And then I'm going to flip it good, right? And so now I'm on multiply. And how you multiply is you factor all of the pieces, right? And so I'm going to, making that kind of into an arrow, that's my next step. So I'm going to factor 3x plus 1. Well, it doesn't factor, so I put parentheses around it to tell myself that I knew that I was supposed to factor, and it didn't factor. It's a binomial without a greatest common factor. It's not a difference of squares, and it's not a cube. And then factor the difference of squares there. X squared minus 49 is x plus 7, x minus 7. And then x minus 7 doesn't factor. And then 9x squared minus 1 is a difference of squares. So 9x squared is 3x times 3x. A difference of squares is an add and a subtract, and 1 times 1. And then now remember we're multiplying, and they said that, hey, well, you can, since it's a multiply, you can say that this all is in one numerator. So I like to just draw the bar across there and make sure that I don't have any funny monomials hanging out, but I just have binomials, so I'm okay. So this is all, these are multiplied in the numerator, and these 4 pieces are multiplied in the denominator. And now you can reduce anything that's in the numerator with anything that's in the denominator, as long as they're exactly the same. So 3x plus 1 divided by 3x plus 1 is 1. And x minus 7 divided by x minus 7 is 1. So that leaves 1 up in the numerator. And x plus 7 times 3x minus 1 in the denominator. And so it was really good for method 2 because there was no work to do for step 1 and step 2. So now we're going to look at method 1, and we're going to try the other problem. And so we'll see what they tell us about method 1. So flipping my paper back over here. Method 1, the first step is you find a common denominator. And then you multiply by that every single term in the numerator and in the denominator by that common denominator, and that clears the fractions. And remember, you're here to cancel, you're here to reduce so that you don't have fractions in the numerator and you don't have fractions in the denominator. So make sure that you do that, and then you simplify it. And then this is just a note of why it works. So in step 2, when you were multiplying the numerator by the lowest common denominator and the denominator by the lowest common denominator, you were multiplying by the lowest common denominator divided by the lowest common denominator, which is 1. And so you were multiplying your original fraction by 1. And so that means it would be equivalent to your original fraction. You multiply fractions by 1 all the time. Like if I had half and I wanted to make the denominator equal to 4, then you would multiply the numerator by, I'll make it, by 4, by 2, and the denominator by 2. So this would be 2 over 4. And half and 2 over 4 are equivalent fractions. They're equal to one another. And so that's what we're going to be doing, but it's going to wipe out our fractions. Watch, it's going to be really cute. And then the next step, after you multiply the top by the lowest common denominator and the bottom, when you multiply, you distribute, you do it to all. And so that's my do it to all. Okay, so we're going to give a try to that here. So we have this problem 18, and we're going to try method 1, which means we're going to look at and get, so that we have a common denominator, we have a denominator of x squared down here. So I'm trying to figure out what the common denominator would be. So I'm thinking about those denominators. So I'm thinking I have a denominator of x squared, I have a denominator of x, and I have another denominator of x squared. Well, it's not necessary if any two are the same to even think about them. And remember how you find the common denominator, you factor the pieces. So x squared is x times x, and then you build it of the factors that you have. This doesn't factor, it's just x, right? And so this says gotta have 2 x's, so x times x is the common denominator. Gotta have 1x, yeah, I already have 1x. This one would say gotta have 2 x's, which I already have. And so that's why it's not necessary to look at it. So the common denominator is xx, or x squared. That's the lowest common denominator. And so what we're going to be doing here, we have 4 minus 1 over x squared. That's what we had. And 4 plus 4 over x plus 1 over x squared. And we're going to be multiplying this top by the lowest common denominator and also this bottom by the lowest common denominator. And that lowest common denominator was x squared. And so, and we're multiplying by 1. X squared divided by x squared is equal to 1. And you have to distribute it. And so that's what I mean by you got to do it to all of the pieces. We had 5 pieces. You're going to multiply every piece by x squared. So how this will look, and I'm just going to write it out, x squared times 4, right, when I distribute here. And then here, this is going to be minus, and then x squared times 1 over x squared. And then in the denominator, distributing x squared times 4. And if you're saying, hey, that's backwards, you're right, I'm going to fix it. If you want to fix it right now, you can. X squared times 4 over x. And last but not least, plus x squared times 1 over x squared. So I usually am kind of lazy and I don't write this step. I go right to this step and I say I'm going to do it to all. And then now I'm physically doing the multiplication on each of them. And so when I multiply those together, oh, well, it's better if you write that as 4x squared. When I multiply these together, now that's x squared over 1, right? And what's going to happen is the x squared is going to reduce with the x squared, and they're going to divide out, right? 1 in the top and 1 in the bottom. So we have this times here. And what if you have something in the top, it will divide with something in the bottom if they're exactly the same and give 1. So this is just going to be minus 1 because the x squares totally drop out. And so you notice that I did have a fraction up here in the numerator, 1 over x squared. And it's just now reduced to 1 by multiplying by x squared. So that's how I got rid of the fraction. And I'm going to do the same to the denominator, multiplying each of those 3 pieces. So this piece, I get 4x squared. This piece, I'm going to write it over here so that it's just a little bit bigger. X squared times 4 over x. So this is x squared over 1. And so that's x times x over 1 times 4 over x. And remember, I was here, this is all one multiply if you like. I'm here to reduce an x divided with an x. And so what that's going to leave left over is an x and a 4, which is 4x. So we had plus, and then we did this and got 4x, so plus 4x. And then the last one to do, remember this is over 1. And x squared divided by x squared is 1, so this is plus 1. And now it looks a lot nicer than it did. It looks like problems that we did in 7.1 where we reduced those. And what they said to reduce those is that you would factor the numerator if it factors. And I say factor, factor, right? Pizza, pizza. And so factor, factor. So I would factor the numerator, I would factor the denominator, and if they reduce, wonderful. Now that numerator right there is a difference of squares. And so that's my buddy, that's my friend, that's my pal. And so I know the difference of squares is a plus and a minus. And to make 4x squared is 2x times 2x. To make 1 is 1 times 1. And then this is a trinomial, the denominator, and it doesn't have a greatest common factor. And so I'm thinking, I got to make that work. So I'm thinking it could be for the first 2x and 2x, and it could be for the last 1 and 1. Now it could be 4x and x as well. And I know the signs are same. That's what this one tells me, right? So that's what it tells me, same. And this one says both positive, right? And so we get that, we know the signs are there. Which one do you think is going to give us 4x in the center? Since these are ones, they're not going to multiply with those numbers in the front. And so I can just kind of concentrate on these numbers because 2 times 1 is 2. And 2 times 1 is 2. Remember, these always multiply together, but if you have 1, it's not going to change it. And so this would, when I'm adding, give 4. But when I'm adding here, that would give, remember this is a 1 here in front, would give 5, right? So it's got to be the 2x, 2x. Plus 1 and a plus 1. And you could write that as 2x plus 1, 2x plus 1 squared, 2x plus 1 squared. But since I'm here to reduce, I don't like to do that because then they're separated and I can say, oh, well, this one reduces with this one. They're exactly the same. And when I divide them out, I get 1. And so my answer is 2x minus 1 over 2x plus 1. And I think that is, I think that is the last problem we have to do. I just had some notes for us about all of the things we've been doing in Chapter 7 so far. So I say, for your information, people get where they really love to clear the fraction. And that's what we just did here on that last problem. Is the method we used was clearing the fraction. And so they say, hey, I have a good idea. I'll go back and I'll clear the fraction on these problems like we did here. This is the problem from the previous day, right? Just one back. And they'll say, hey, let me get rid of the fraction. And you can't clear the fraction. See how I still have a fraction? And there's only 2 times that you're allowed to clear a fraction. And so that's what the note I'm making here. So people love to clear the fraction, and there are only 2 circumstances when it's okay to clear the fraction. And that's when you have a complex fraction or when you have an equation that involves a rational expression with a left-hand side and a right-hand side. Those are the only times. It is not appropriate to say, I'm going to clear the fractions. It's not a method that would work if you're just simply simplifying a rational expression, or when you're adding 2 rational expressions together, or when you're subtracting 2 rational expressions, or when you're multiplying or dividing. So anyway, so just so that you know that. Okay, my friends, well, this is a short video, and we did need a break because those other videos were kind of long.